Welcome everyone to the Priva Academy live training session. My name is Brianna Parker and I'm the marketing coordinator here at Priva North America. So we want to thank all of you for your patience today as well. We encourage you to ask questions throughout the session today. Feel free to chime in if you have any comments. You can either unmute yourself or throw your questions in the chat and I'll be sure to work those in for Nicola here today. As always, we do love to hear from you as well, if you have suggestions or topics you'd like to cover in the future. So today we're going to be covering quite a popular topic, it seems like, the modulating lights and PAR I-20. So some of the topics we'll be touching on will include multi-channel modulation, the role of far red, and PAR-based light control, and obviously quite a few other things here as well. There will be time for open questions. As I mentioned before, you are welcome to ask your questions as Nicola goes through the presentation today. But for anything that we don't touch on, there will be time for you to have those discussions at the end of the session. So again, feel free to unmute and chime in or put your questions through in the chat and I'll be sure to work those into the training. So I believe we are all set to get started. This is Nicolas Lacroix, and he is one of our Priva system consultants here at Priva North America. Go ahead, Nicolas, take it away.
Yeah. Hi, everybody. My name is Nicolas Lacroix. I'm in Quebec, Canada. I'm working with Priva North America. So that today that will be Connext modulating light control and PAR. So if you have a question at the end of each module, we'll have some time to answer your question. But if you have any question, just let me know during the training, as Brian has said. So we'll start with, what is the difference between HPS and LED? Just a quick review. I think most of you already know, but as you can see, the HPS produce a lot more heat than the light. So they produce 11% convection heat, more or less, radiation heat 55%, and light about 34%. Compared to the LED, which produce 26% convection heat, 11% radiation heat, and 63% lights. Okay, so here that's just an overview of the wavelength spectrum. So it starts with the gamma and it finishes with the FM radio station. Today we're going to see we'll more focus on the visible light, which is between 400 nanometer and 700 nanometers. And that's also the light spectrum, the wavelength spectrum that the crops use the most. So most of the LED produce only that wavelength, so between 400 nanometer and 700 nanometer. So if we compare that to the HPS, so they produce a lot more wavelength. So there's unnecessary wavelength for the crops. So that's why they are less efficient than the LED. So if we start with the LED, we see most of them produce a wavelength between 400 nanometer and 700 nanometer. That's the PAR light that is mostly used by the crops. But the crops also use the far red, which is a wavelength between 700 nanometer and 750 nanometer, which is also used by some crops. The far red cannot be measured by the PAR sensor. That being said, there are some new PAR sensor that can measure that wavelength between 700 nanometer and 750, but most of the actual PAR sensor cannot measure the far red. So how do we control the far red then if you cannot measure them with the PAR sensor? So the solution is to have a second channel, a separate channel that will be controlled independently. Okay. Now these days we can see that we have a LED with one channel, most likely is the 400 to 700 wavelength. Then you have two channels, one channel for the PAR, one for the far red. And you can also have multiple channels with separate color like PAR, white, far red. You can have more than 3 channels as well. In the Priva control, we can control up to 7 channels per light system now. So the solution to control that is the light control module in Priva. Today we're going to see the Connex version 9.15 release 2. There's been a lot of improvement over the time with the Connex version to control the light. So I will focus more on that version, which is the one of the latest release that gives you more flexibility for additional modulating channel in that version. So when you decide to install a project or start a project for LED, what information do we need? We need to know the quantity of fixture that you will install, the area that the light cover in square meter, the specification from the manufacturer, such as electrical capacity for each fixture in kilowatt, the maximum intensity in micromole per fixture or per compartment, the signal needed to modulate the LED. So over the last couple of years, there's been a lot of improvement on lights. So we start with full HPS control, then we go to on-off LED and HPS, so hybrid system, then modulating HPS LED mixed with HPS, and now these days most of the installation have full modulating LED. There are still no standard from the manufacturer, so we have to be flexible on how the control work, and but we can adapt to most of the system now. So it's important when you start a project to know which signal you need, because the cost for the installation can be different. So like if you have a 0 to 10 volt signal to control on the LED, or a 4 to 20 milliamp, you just need a Connex system. But if you need to control by BACnet or Modbus or another communication protocol, then we'll need to interface the LED controller with a Priva Blue ID system. Okay, so let's start with the light control software. So that's I think the most important part for you today. The first thing you need to do is the allocation of the different component of your system. So in page I20.4, you need to allocate the outside radiation sensor. You can also allocate the outside radiation sensor and the inside power sensor, the measuring box to the light control, the light control to the growing lights, and also the diffuse and the shading curtain. Today, I'm not going to cover the diffuse and shading curtain because, yeah, there's enough stuff just with the light control. Okay. So as you can see here in I20.4, you have the table to allocate all the equipment. The link that you will do here will affect the way the lights are controlled. So that's really important to understand that part. Depending on how you want to control, you need to do the link different here. Okay. We'll start by just if I only allocate the outside radiation sensor here, that's a mostly easy part to do. So no power sensor at all. In the page I20 here, you have the determination of desired light. So that's your main control page. So you have different period with different power lighting level. And you have also another table here with the recipe, the steps, and the maximum intensity. So we'll cover all that during the training. So in the first table here, you have to set your period, and you have to set always a night period. So that will be your end of day where there's no light during that period. Okay. So you set your start time with power lighting intensity here. So if we see here, if we can see here that I set my first period for 130 micromole, then the other two periods are 80 micromoles here. So that's my desired bars level. Okay. You can also simulate the sunrise and the sunset. So if you see here, and also it's always in page I20, line 29, time par increase start day. So that means that every 30 seconds, you will increase your power lighting level by 10 micromoles. So we start from 0, it's the beginning of the day, and after 6.5 minutes, I will be at 130 micromole. So I will simulate the sunrise. So if you want it longer, you can put a bigger number here. And you can also simulate the sunset. So this is the next line here. So I set it to 1 minute. So 1 minute per 10 micromole. So it will take 8 minutes to dim down to 0. You have also another setting here, time power decrease per 10 micromole, time power increase per 10 micromoles. That setting is for the transition between the period, and that's also applied to the influence as the irradiation to adjust the power level, the extra influence, and the power sum influence. We'll cover that later. Okay, so in the page I20.2, there's two really important tables there. So line 4, that table, it's the maximum output of the fixture, measured or provided by the manufacturer. So that's really important that you set the maximum output in micromole of your fixture there, because all the control will be based on that table. Okay. So I set 150, so which is my maximum output for my fixture at 100%. So when my fixture is at full capacity, I can get that quantity of micromole. So now, if my first period is set at 130 micromole, then I will ask my fixture to go at 85%. Okay. So without any influence, my fixture will automatically go at 85% and stay there. But if I fill the line 5 here in high 20.2, I can decrease my fixture level by my light level with the outside radiation. So in that table now, I set it to start at 300 watt. So below 300 watt, there's no modulation. But as soon as I go above 300 watt per square meter, I begin to dim my light until I reach 600 watt per square meter. Okay, so that will look like that. So my light increase here, and then I start to decrease my LED. Okay, so I will show you on our demo, so how it looks like. So just bear with me for a second.
Nicola, we do actually have
Yep.
a question in the chat here.
Yep.
From Jen, wondering if we can go over HPS as well, or only LED.
You can go also with HPS. If it's on-off HPS, you can still control the HPS with the light control. They will go on steps, so you can have up to a maximum of 8 steps, and but they can be controlled. So you can do 50%, 100%. They will go on step, or if they modulate, I haven't seen a lot of HPS modulate, but we can do on-off control as well. Yeah, that's not a problem. Good.
Okay, great. Thank you, Jen. I hope that covers your question there.
Good. Okay, so here we have the link that I told you. So I link my light control to the weather radiation sensor. And I will unlink it here. So you can see already I will remove this link and the table here will change. Okay.
Sorry, Nicola, we've got another question here in the
Oh,
chat.
sorry. Okay.
No problem. From
Yep.
Sebastian. Is there a way to control the speed of the LED modulation?
Yes, we will cover that later, but yeah, there's a way. Yeah.
Fantastic. Thank you.
Okay, so you can see here the table change, so I have less option to control my LED now. Okay, so if we go in our settings here, so that's that one here, sorry. Okay, so you see here that's my period where I can set my power lighting level. Okay, and in HID light here, I can also set my maximum output for my fixture. So for for that demo, I just set it to 100 and at 100% to make it easier. And now you have radiation reference decrease light percentage. So you can set the table so you can dim the light as the outside radiation increase. Okay. So that's, and you can see here in the realization, you will see in that one, you can see the use radiation. So that's your outside radiation sensor. Also the light percentage that is calculated from power lighting. And here that's there's some delay in the calculation, but I will show you that later. But that's more likely the real output of your light. Okay, so we will go to the other way to control. Now I allocate my outside radiation sensor and my power sensor. Okay, so I allocate both. We recommend to install at least 2 power sensors and control on the highest measurement. The reason is if you have some shadow on one of the sensor, you don't want the light to increase really fast or change really fast. So if you have 2 power sensor and you control on the highest one, the chance that you have shadows on both sensor at the same time, is are better. So. Okay, so now let me see here. Okay, allocate both here. Okay, so I have allocate both. Now you can see here that I still have the same table where I need to fill my maximum output of my fixture, line 4. It's the same, but here it's not radiation anymore. It's power reference to decrease light percentage. Okay, so you can see here I have 2 new settings. Use outside measure radiation to decrease light percentage. I set it to no because I want to use the par, so that refer to that line here. And use par correction for light percentage. I leave it to no for now. We'll explain later how it works for that. Okay, but let's start with both at no. So that means I only use the par reference to decrease the light. Okay, so if I set my table like that, if I have a difference between the output of my fixture and the measure par of 100, then I will dim to 100. Yeah, 100%. So which is switch off the LED. Okay. So if I set it to 130, I will ask my fixture to go to 85% here. Okay. And here you can see what will do the power reference decrease lights. So that's a bit tricky because it's different from the radiation. So it's really my calculate output of the fixture compared to the measure power level. So as soon as I have 100 difference here, I will have dim my light completely. So they will be switched off. You can see the difference between the actual growing light, calculate output, and measure power will dim the light. The influence light reference show you how much the light are dim from that calculation. So here, that's normally my actual growing light level. So you will see a number of micromole here that is calculate from the LED. And this is my use par, that's my measure par level. And in line 24 here, you see the influence that difference. So according to the table, so now I have minus 3% calculation here. Okay, I show you that on the demo now. So now I set my par sensor to a light control. So we'll see that the table will come on. Okay, so use outside measure to decrease light. So we'll set no. I want to control my par on the highest one here. Oh, I'm not on the right ones. No, that's good. Okay. So I should have another one that come on here. It takes some time, but yeah, that will be another no there. So I will go forward with the rest. So I still set my par lighting here. I have my table for my reference, and now par reference decrease light percentage. So I can, depending of the difference between the measure and the control par, I can dim my light according to that. If we go to the realization, so the actual growing light calculate 100, and my use radiation is 98. So I'm a bit below. So there's yeah, it's almost the same. But so if I cannot play with the actual radiation, but normally you would see the inference light reference here that could dim the light if the light level the difference was too big between them.
Question here for you in the chat, Nicola.
Yeah.
What is the difference between I-205 and I-20 pages?
Yeah, that's a good question. So you have to choose. So if you have I-205, that's more for the HPS that you use this page, but they both doing almost the same, I would say. So, but you have to choose. You can use I-20 or I-205 if you have both in your system. But that's really, yeah, I-205 is really for on-off HPS and I-20 for the modulating line. But you can still control from I-20 the HPS as well. It's a bit different, the weight control, but yeah.
Okay, great, thank
Good.
you.
Okay. Good. Okay, so now if we still allocate both here, but now I want to, the only difference that I will do, I will set my use par correction for light percentage to yes here. Okay. So what will happen, I still have my table here on line 5, par reference decrease light. Still my output for the LED. So if I'm set at 130 and I ask, I ask 85, yeah, I'm at 85% of my fixture, then we can see the same. So my par reference to decrease light. So what I did here, I start to decrease at 100 difference. And when I'm at 200, I only dim at 75%. I don't want to turn off completely the LED. Okay. So the par reference here, decrease light, is act more like a p-band. So you can decide how fast the correction will be with that table here. And the par correction for light percentage, you remember in I-20.4, the yes that we turn on. So if there's a deviation between the measure par and the set point in I-20, the light will be decreased 1% every 10 moles, difference every 2 minutes. So that's really a slow correction, but I have a lot of installation that only use that and it works fine. So depending how fast you want to react, so you can only use that or use that in combination with that table. So you can say, okay, at a certain level, I want to dim faster because I know that I will overshoot my par level too much. Okay, so we see here the par correction. We dim with the par reference decrease line. So line 5 here. And when I'm at 25%, then my par correction will take over and slowly dim to 0%. So you can see the par correction for light percentage will be calculated based on the difference between the set par and the measure par. You can see the correction on line 24, influence light correction. So that's really the difference here. So my set par, so that's what I want to have on high 20, and my use par, which is the measurement. And you can see here the correction. So like here I asked for 80 and I'm only 16 now. So I have a correction. So it will slowly, it asks the fixture to go 27% higher than the calculate 16% here. So if the power lighting level is set higher than the fixture maximum output capacity, the light will begin to dim based on the difference between the power lighting level and the measure power. Let's say you have a fixture that only provide 150 micromole, but you want to have a set power at 500. You can set your power at 500, and it will begin to do the power correction only when you're around 500 with your use power here. Okay, I'll show you that on the demo. So I'm not sure why. Not sure. I should have the power correction here. Not sure why it's not working. Okay, yeah, I'm not sure why it's not thing. Let me try to refresh the page maybe. Okay. So yeah, anyway, you will not see any change really in the control since it's really the power correction. The only thing you will have an extra line in your M20 page here that will show you the power correction here. So that will be an extra line to show you the power correction based on the difference between the set power and the use radiation here. Still not there. Or okay, I will continue with the rest of the training. So light control, you can allocate outside radiation and power sensor again. But now that time you can set both line 13 and 14 to yes here. So what will happen instead of using the PAR, the inside PAR to decrease the light, you will use the outside radiation and the PAR correction. So you can use both. So still setting at 130, asking 85% of my fixture. So now I set my radiation reference decrease light percentage that decrease the light based on the outside radiation, like we saw before when we only allocate the outside radiation sensor. Now, if we see the combination of both, so the PAR correction, if there's a deviation between the measure PAR and the set point in I-20, decrease the light by 1% for every 10 mole difference every 2 minutes. And I also set my radiation reference decrease light percentage to start at 300, and at 400 I'm dim at 75%. So that looks like that. I have my PAR correction. Then when I hit 300 watt per square meter, I begin to have my PAR rad reference decrease light. And when I hit 25%, so 75% dimming, then the PAR correction take over. Yeah, that's the same PAR correction based on the set PAR and the use PAR, and you can see your use radiation here. You will have the influence light reference and the PAR correction that can both dim or increase your light level. Any question about that module? No? Okay, let's continue then. Now we'll see the light control. So the PAR sum and the influences. So that's in page I-20 here. You have your desired PAR sum, which now I set it to 30, probably a bit high, but yeah. So the PAR lighting level can be influenced by the PAR sum. The control will reduce the PAR lighting level if it calculates that the PAR sum will be achieved before the night period. The PAR lighting level can be influenced no more than the max increase and decrease PAR sum. So if you turn that on here, the control will aim to have that desired power sum at the end of the day. Okay, so it can influence your power lighting level by at a maximum of the maximum increase and decrease power lighting level here. Okay, so that means the control, if my power sum is too low, I can increase up to 180 micromole, and if it's too high, so I can go to 0. The maximum power sum influence cannot be more than the max increase or decrease power sum. So here you can have influence on your power sum directly, so that will not influence your power lighting, or indirectly that will influence your power lighting. But here that's a maximum that you can influence your power sum, not more than 100, which is too much. The power lighting level can be influenced by irradiation or any connected extra influence or humidity there, depending on what you link to the control. The power lighting level can be influenced no more than the max increase, decrease power lighting. So that's the same setting here that apply for line 7, the high power sum influence, irradiation adjustment bar, and extra influence here. There's another setting in page I20.2 when you can decide to have some step off depending of the related to the power sum. So if the difference between the measured power sum and the calculated power sum is less than 1, in that case here, then the step 8 cannot turn on. So my calculated power sum is 30. If the measured power sum is more than 29, the step 8 cannot turn on. So if the step 8 is already on, it will stay on. But if it's not, it will stay. It will turn off. Okay. It will stay off, not turn off. Sorry. And then you have another setting here. So if the difference between the measured power sum and the calculated power sum is less than 0.5, then step 8 is turn off. So if step 8 is on, then it will be turned off. Example, my calculate power sum is 30. I have 0.5 here, so if I'm above 29.5 with my measure power sum, then the step 8 will be turned off. Any question about that part, the influence, or that was an easy part? Yeah. Okay. So now we will see the steps and the deadband. That one is not easy, but yeah, you will see. Okay. Just note that in Connext version 9.14, the step works only when they are connected to electricity management. In Connext version 9.15 release 2, the step works with or without the electricity management. So that's this part. If you want to delay your modulating light to go on and off, that's really with the step control here that you will achieve that. Okay, so in 9.14, unfortunately, you don't have that if you don't have the electricity management. They add that for all the control in version 9.15 release 2. So why are we using the steps? It's mainly for electricity management or to delay the modulation. So that can be used for both. Okay. So yeah, for the electricity management, that's used. So if we are at a certain step, we will ask a certain kilowatt demand to CHP or to the grid, depending. If you have a limitation on the grid, you can limitate the number of steps for the modulating light. Okay. So here you have to divide your step in percentage. So you always start, the first step is the minimum capacity of the fixture, and you divide the rest between the remaining step. The minimum capacity must be set in the dealer level. So that one is really important. In the dealer level, they are setting for the minimum capacity. If it's set to 0, even if you have your first step here at 16, the light will be able to modulate below 16. So that's a really important one. Okay. So normally the manufacturer will tell you, okay, my minimum light is 20% or a certain number. So just follow the manufacturer recommendation for that. In page I-20, you have a setting where you can put the maximum number growing light step. So you can do a period with 6 steps, the other one with 7, another one with 2. Okay. And page I-20.2, that's where you set your percentage for each step. So the steps are used to delay the light to go too fast from 0 to 100% here. So we can see the percentage. Okay, so how it works. That part is a bit difficult, I will explain, but honestly, you don't have to remember everything. Just understand the principle will be enough, but yeah, we'll go in detail. So the light, so when the light calculates 17%, the deviation sum will begin to calculate. The deviation sum for the first step is calculated based on the half of the difference between 0% and step 1, plus the deviation. So in that case, my first step is at 16%, so half of the difference, so it's 8%, and I'm asking for 17%. So my deviation sum will be 8%, so the difference between 8 and 16 plus my 1%, because I'm asking 17. I will have a deviation of 9% every minute. Okay, so the control will calculate every minute 9, and it will add that every minute until it reach my set deviation sum here for the step 1, which is 36. So after 4 minutes, my lights will turn on. When my first step is approved, I have free modulation between 16 and 27. Okay, I cannot go above 28. That's for my first step only. For the second step, so now I desire 29, which is above the second step. I have another setting here for all the remaining steps. Okay, so 12% here. So the light modulate up to 27% when the demand increase to 29 above the step 2. The light deviation sum is increased. The desired 29% counting from 28, deviation of 1%, the par sum increase of 1% per minute. On its field, the second step turn on, it's allowed to increase to 34% maximum. It's half between step 2 and step 3. Okay, so when my second step is approved, I can go up to 34% here. Now I desire 36%. So it's above my the middle between the second step and the third step. So the light modulate to 34% because the light are low to do that. When the demand increase above 34% in the middle of 28 and 40, the light percentage deviation sum is increased. So my desired level now is 36. I'm counting a deviation sum from 34. My deviation sum is now 2. So that will take 6 minutes before I turn on my third step. On its field, step 3 turn on, it's allowed to increase to 46%, so between 28 and 46, and the story repeats itself for all the remaining steps. The light will begin to calculate the deviation step off as soon as you're below the previous step. So step 2 here. When the deviation sum off is reached, it will go from step 3 to step 2. So you have another setting to dim down the light here. So now it's set at 6. So as soon as I'm below the 28, it will begin to calculate a deviation sum like that. The light will begin to calculate a deviation sum step off as soon as you're below the previous step, step 1. when the deviation sum is reached, it will go from step 2 to step 1. Okay. So below step 1, it begins to step off, but I will go to step 1 when I'm there. Oops, sorry. The light will turn off only when the calculate demand is 0. So even if I calculate below my 16%, the light will stay off at least at the minimum percentage here, if it's set in the dealer level. And when I calculate 0%, then they will turn off completely. You can also set some deadband on and off. The deadband on, the deviation sum will begin to calculate only when the calculate percentage is above half of the percentage between two steps plus the deadband. So I mean, here if I'm supposed to start my deviation sum at 46, I have a deadband of 2%, and then it will only begin to calculate at 48%. It's the same for the deadband off. The deviation sum will begin to calculate only when the calculate light percentage is below the step percentage minus the deadband here. So you have your deadband on, deadband off here. Okay. Example, so 28 minus 3%. So I will start only at 25% to count my deviation sum. You don't really need to use the deadband, especially if you don't have electricity management. There's no real use to do that because there's also already deadband included with your deviation sum. And there's another setting below the deadband and deviation sum. There's a table here. It's the sun height factor. It will increase the power sum and the deadband to delay the light to turn on slower or turn off faster. For example, if you have an orchid grower in the morning when the sun is low, so the angle is low, they want the light to turn on faster and turn off slower. So as the sun angle increases, they want to delay the light to turn on and off the light faster. So you see here, you have new line when you fill that table, so that will influence your deadband and your deviation sum with the factor that is set here, okay, depending of the sun angle. So it can take more or less time depending of the sun height. So it's a bit complicated. If you have one thing to remember, a bigger deviation sum equal a slower reaction, and a smaller deviation sum equal a faster reaction. So you can play with this number if you find that it goes too fast or too slow. But yeah, you don't have to remember all the step one by one. But hopefully you will understand a bit better how it works now. Any question about that?
We do have a question in the chat here.
Yeah.
On Connext 914, the light will not modulate within the growing step due to electricity management. And how do you connect the electricity management?
Okay. Yeah, the electricity management needs to be connected by your dealer, but you need to have the module that is the software for electricity management. Most of the greenhouse in North America don't have that software. So, but if you have the software, it can be connected, and the step will work as I showed before. So, good.
I think so. Thank you.
Yeah, okay. So I will just show you on the demo more or less how it works with the step control. So you will see that will give you a better idea. So I know it's a bit complicated to understand. So okay, I will just turn. Okay, so that part correction is there now. For that, I will just remove all the influence, so that will be easier to play with the light percentage. Okay, so now I am asking, you see that in my overview here, that all my steps are on. Okay, so now I will turn off the lights. So I'm set to 0. And here, HID light, we can set the deadband. So I have set the deadband to 5 now. So you see it still calculate 100%. Now it calculates 0. Okay, but it's only allowed to go to 84 for now because it's stepping off. Okay, so now there's a big difference. So it will step off really fast because I go from 100 to 0. The deviation sum is really big. Okay. So we'll see it will step off one by one like that. And when you see weight off, that's the time that the control takes to adjust the light. Okay. Show you. If you go to page M208, which is the new M205 page for the LED modulating light. So we can see here the real, what is the percentage of the channel. Okay. So now it's 63, but it asked for 48, so it should dim down. So it desired 48, but it's not there still. So that's why I'm at weight off here. So that's really the time that it takes to the fixture to dim. So now I'm 38, it goes to the next step. So we are almost off now. Okay, so it will turn off eventually. So if I go here now, I will put the set point at, remember I just put number, my table is set, make it easy. So my table is set 100 micromole equal 100%. So the number of micromole that I set here is basically the same as the percentage. Okay. So now I will set 15%. So you see that my minimum is set at 20 here. Now I also have a par sum of 5 for the step on. So you see it begin to calculate the deviation sum light slowly. So when we will reach 5, you will see what will happen. Almost there. So you see my channel 1 is still at 0. So I'm calculate 15%, but I'm still half here because I'm not ready. So it wait to be on. So it will go directly to 20% because it cannot go below 20% here. So it should turn on eventually. Not sure if I have a problem. Yeah, that's a demo. So maybe here. Here you have a page for the modulating light. If there's a problem, you can reset the failure on the channel here. Anyway, I think I will continue to show you how it goes. So if we increase a bit more here in my light control strategy. So if I ask now 34%, so it should change here the power lighting, to calculate power lighting percentage as well. Okay, so now my step 1 is on, and I already begin to calculate the deviation sum. So I asked 34, but I'm only allowed to go to 30 because that's only my first step that is on. So it really delayed the control. Now I have my deviation sums fill out. So it will wait to be on. So it will ask for 34% now. And if you ask a really high percentage, so like if I ask 100 here, then you will see the calculation go to 100 here, but I am still black at 37 because I'm halfway between these two steps still. But the deviation sum will be calculated really fast from now because I'm asking a lot more than my actual position. Yeah, and it will go like that until you reach 100%. So no question about that? Good. Okay, now we'll see the recipe and the inference. So how to control different channel. So that still connects version 15 release 2. If you have 9.14, you may not have all these options. Okay. How the inference work on the light control. So here in the page I208, there's a total of 6 recipes available for each light control. And in I20.2, you also have other settings for these recipes. In your page I20, you can select a recipe for each of the 6 period. So you can have different recipe. It's just above the maximum light step here. And here in I208, there are some symbol on the right side of the percentage here. They are really important. So an arrow down mean it dim based on the radiation. So you set it to 100%. Equal sign mean it follow the dimming but reduce with the factor. ABC, it's not influenced by the light but by extra influence. You can be used for far red, white, or any extra channel that you don't want to control with the light itself, with the par. Okay. So dim based on radiation. So it's important to always set that one to 100%. And the equal follow the dimming but reduce with a factor. So for example, if your channel 1 is 80% and channel 2 will be at 40%. So that's 50% of channel 1 always. So it will really follow my channel 1, which have the down arrow. Okay. So these two channels will be controlled with the table that we saw here earlier. And high 20 here, that will be my power lighting level, so that will control these two channels here. If you select A, B, or C, they are not influenced by light, but influenced by extra influence. It can be used for far red, white, or any extra channel, always set to 100%. If you don't set this channel to 100%, like I did here, so I have one set to 50, then you will have an extra line here in your when using A, B, or C. Yes, so just set that back to 100 and that line will disappear. Okay. So in height 20.2, how it works. So I have a link an extra influence to my channel A, which is my greenhouse temperature now. Okay, so I set my percentage to 100 here. So that's my starting point. So if I'm set at 100%, the light will turn on at 100% if there's no influence. The influence needs to be set negatively. So that's really important. If you want to dim, you need to remove some light intensity based on your influence here. If you set that number to 0, then the light will be off at the beginning if there's no influence, and the influence needs to be set positively. So as my temperature increase, I increase my light percentage. Any question about that? About recipe or light? I will show you on the demo how you adjust that. So I28 here. So you can see here I have 4 channels. So my first channel arrow down, second one equal sign. I have my A and my C. And I will go to I20.2, where you have your extra influence. Okay. So I have my first channel, A is set to 100, then I fill my table with a negative 100% to dim down my line. That one is set to 0, then I have a positive influence here. So how to connect the extra influence? So you just have to click here on the little tool, and you can choose any of the influence that are here or search for anything. And then you link, you just have to link like that. You do adjust, yes. And then you just have to go back to your previous page. So now I have an influence linked to the B. So my autonomous heating set heat temp is not linked to my LED, so I can use that table to dim the light that are connected with B here. Okay. If you have an extra influence that you or a setting that you cannot link with that table for the extra influence, the dealer can also link some any data point in the background, so you can ask your dealer for that. So that's it. Thanks for your attention. So that was the modulating light training. So don't know if you still have a remaining question or interrogation about that.
A couple minutes here for some questions if there's any. Feel free if you've got a question to unmute yourself or to pop it over in the chat there as well, and we'll read that off and answer those for you. Okay. Not
Good.
seeing any questions come in here, Nicolas.
Yeah.
So
Okay.
I think we're good. So in that case, we do hope that you've learned something new and are able to walk away with a better understanding of how Priva can help you or your clients kind of optimize your lighting strategies and how to better optimize those. We know Nicolas covered a lot of different information today. So there is a recording that will be available of this session on the Priva Academy starting next week that you'll be able to review. If anybody wanted to revisit some of the topics discussed, or if you have any unanswered questions as well, feel free to reach out to us. We're always happy to connect with our customers and would also appreciate feedback on the live training session as well. Again, if you have suggestions on topics that you'd like us to see covered in the future, please do let us know. You can put that right through in the chat and we'll be sure to review those suggestions. Nicolas, is there anything that you would like to add?
No, that's it. So just, yeah, feel free to contact us if you have any question. And yeah, we are there to help you. So yeah, thank you for your time today. And yeah,
Yes.
talk to
Yeah.
you soon, I guess.
Absolutely. Thank you everyone again for being here today and supporting Priva. Wishing you all the best for the rest of your week and hope to be in touch again soon. Thank
Thank
you.
you. Bye.